everyone, welcome to another episode of Learn All Things Cyber with T. As I promised you last week, I said we'll be talking about IP addressing and subnetting this week. But as it stands, because we need to take IP addressing slowly, people who are very familiar with networking knows that this is a very important topic, and this is also a topic that some cybersecurity people try to avoid because it is hard. So we will be talking about IP addressing. Basically, next week we'll take up the subnetting. So I would start. So when we say an IP address, what do we mean by IP address? So if you remember in the past lessons that I taught about OSI model, I mentioned that when your devices are communicating with each other locally within your network, they are operating on layer 2 because they're actually using the switch. If you remember that I was also explaining the difference between a switch and a hub, how that a switch is a smart hub. Now for IP addressing, it is connected to layer 3 because this time your device wants to communicate with something outside of your network, communicate with the internet outside of your network. So that's why we have IP addressing, and it of course occurs at layer 3, which is the network layer of the OSI model. So what is IP addressing? I'll give you a simple example so that you can understand what an IP address means. So I'll be writing a physical address of a house. So say right. So this is an address, a full address of a house. This is the street name. This is the house number. This is the room number of the person. This is the postcode. This is the city, and this is the country. So why am I writing a real address? Now, say for example, I live at this address. I don't live there. But just in case, that I live at this address. And then somebody is trying to send me a package, for example, they need this full address to be able to get that package right to my doorstep. Now, that is what an IP address means. An IP address means, say, your home address. It's like a unique identifier that identifies a device on your network. Say, for example, you have like 3 devices on your network. They are going to have 3 different IP. There's a portion of the addressing that belongs to the network in general, that 3 of them will share. And there's a portion that will belong to the host. And when I mean host, I think I've explained this before. So host is like your laptop. Say you have 2 laptops, those are hosts. You have a phone, you have a tablet. So that's how IP address works. IP address works as if it's your home address that will deliver data. So I will break it down and keep it simple. So for example, you're trying to get to YouTube from your phone. You say, hey, internet, I need to get to YouTube. Now, what IP address does is that IP address is what that is that address that helps the internet to deliver the right data back to your phone. So because you wanted to check for YouTube, you won't get the results on 5 different laptops because they are on your network. You will get it directly to the phone from which you have actually sent out requests for this resource. Maybe you want to check a YouTube channel or you want to check a video. So that's how IP addressing works. And we have like different, versions of them. We have version 4 and we have version 6, but I will be going into version 6 much later because it's the newer version. It's not, a lot of people are not using it at the moment, but the version 4 is the one I think people are more familiar with and is the one that is actually common right now. So I'll be using the version 4 to explain how IP address looks like. So we will go to IPv4 now. IPv4, and I'll give you an example of how an IP looks like. An IPv4 looks like, say for example, 192.168, say for example, .1.4. Now this is an example of an IPv4. This IPv4 you're seeing, it's in the dotted decimal form. So dotted decimal form that you can read. Now, this particular IP actually contains octets. Like each of them is 1 octet, 1 octet, 1 octet, 1 octet. And each octet makes up of 8 bytes. So 1 octet, 8 bytes. And I would explain this properly. So you know that computer language is in binary. Now this is human readable language. For computer language, we have things like ones and zeros. When it's on, is 1. When it's off, is 0. I think I'd explained this before when I was trying to explain, I think, the first layer of the OSI model. So now let's look into what the binary looks like. It's just an example. Now to know what the binary looks like, you need like a table figure or something like that. And I would explain this further later. Say, for example, we have 1. 1 multiplied by 2, you have 2. 2 multiplied by 2, you have 4. 4 multiplied by 2, you have 8. By 2, 16. By 2, 32. By 2, 64, right? By 2, you have 128. You don't need to cram this number. You just need to know that it starts from 1. And we are trying to dig out what the binary would look like. So, say for example, you have 192. Now, to get what this 8 bytes looks like in binary form, that's what I'm trying to explain. So, I want to show you the difference between the dotted decimal part of IP, because you will need it when you go further in the line, talking about class, talking about subnetting, and that's why I'm bringing it out basically. So, say for example, you have 192. So basically, it's like ones and zero. So addition of 1 and that makes up this number. So let's tackle this first octet. It's 192. If you look at this number, which number would make up 192? It will be 128 and 64. So the combination of them will make up 192. So I'll put 1, 1. And it's already complete, because if you add it together, it's 192. Now the rest will be 0, 0, 0, 0, 0, 0. Now, if I want to write the binary form of this 192, the binary form, because you remember I told you it's 8 bytes actually. So it's just in one decimal place, but it's one octet each of them, which makes 32 bytes as a whole, because 8 times 4. So now for this, we have 1, 1, 0, 0, 0, 0, 0, 0 to make 8. Can you see? So now if we're looking into what 168 would be, so 168, and remember, each of these octets can go from 0 to 255. Now, if we want to look at 168, let's look at it together. So 168, this plus this would give us 64 plus 32 will give us 96, right? Yes, 96. Or we can even take it from here and say 128 plus 32. That's 160, and then 8. I don't know if you understand. 128 plus 32. So 1, 1, and then 1. The rest, we put in zeros. 0, 0, 0. So when you want to write 168 in binary form, we are writing 1, 0, 1, 0, 1, 0, 0, 0. I hope you understand what I'm trying to explain here. Now, when it comes to dot 1, we already have 1 within this number. So 1 will just be 1. And the rest will be 0, 0, 0, 0, 0, 0, 0. So 0, 0, 0, 0. 7 zeros. Then 1. 4. We also already have 4. Here, we'll put 1. This one will change into 0 because 4 is complete on its own. So we have 0, 0, 0, 0, 0, 1, 0, 0. So these are the differences between dotted decimal and the binary form of what an IPv4 looks like. I want you to understand this part because we would end up coming back to use it. So they usually call this like computer mathematics. I mean, just like I was creating mathematics. So when you understand this, when you get to subnetting, it's easier for you to understand. So I've added this image to further show you what it means to convert an IP address which is in dotted decimal to binary. As you can see, the same numbers I wrote 1, 2, 4, 8, 16, 32 and 64 and 128. So we're trying to convert this 172.16.16.254.1. Again, remember I said that for each octet, the ranges can go from 0 to 255. And why we omit 1 is because that particular one can be used for. So basically that particular IP that you don't see is usually used for a broadcast address. So usually IP ranges goes from 0 to 255, and as you can see, if you add up these numbers, this 1, 2, 4, 8, 16, 32, 64, you'd also arrive at this total number. So let's quickly move to IPv4 class types. So we have different types of, IPv4 addressing, based on class. We classify them based on their class type. Now I'll explain what that means. But in the early part of the video, I was mentioning bytes for some weird reason. So what I mean is actually bits. So there's a difference between bits and bytes, as you know. Bits is this binary form or data form that is always in ones and zeros. Bytes is actually for, a file type kind of thing, like megabytes, gigabytes. So this is different from this, and this is usually addressed as small letter b, while byte is usually big letter. So I just wanted to correct that part before we move on. Now remember I showed you what an example of an IP address looks like. I was mentioning something around 192.168.4.1 that we used in the previous example. Now, based on class, we have rules that classifies IP address. Now we have class A to E. Now I'll explain what they mean. So they are classified based on their first octet value, and which also classify their subnet, which result into their subnet mask, their default subnet mask, and I'll explain. So now we have these values are not something you cram. I think you probably know it, but if you're very familiar with home network, you will notice that most of our home network are always around this class C, actually. So usually the value of the first octet, remember what I call the first octet, this one. Remember I said each of them are octets, 8 bits. Each of them, and I explained that using the binary format previously. So now from 1 to 127 usually belong to class A, and because it belongs to class A, you would know that the subnet mask for class A usually stays at 255.0.0.0. And what does this 255.0.0.0 mean? I said that an IP can actually have the host part and the network part. Now the network part just looks like, I can explain it in layman language. So say for example, the network part is like our neighborhood, where I'm living right now, the neighborhood. The neighborhood would mean that from that address I showed you previously, I showed you something like 32. So say people that are living in 25 to 30, we're in the same neighborhood, we share that same street number. But my room number is the one that actually make me unique from every other person. So when I'm ready to receive a package, the package comes directly to me and not to any other person in that neighborhood. So the network part is like the neighborhood. So for your home devices, every device in your home network share the same network part. Say for example, every device will share 192, 168, and 4. But your phone might take up 1. Say for example, your laptop might take up 2. Your tablet might take up 3. And that's because it's actually class C. And this is what I'm trying to explain. So now, to distinguish between what is the host part and what is the network part. For the network part, now let's go back to binary. And that's why I said it's good that I showed you the binary. So using the binary, the host part is usually the part that has the ones. So, the network part. So the network part are the part that have the ones, while the host part are the parts that have the zeros. So for class A now, as you can see, 255. If we try to add all those things we had together, that 128, 64, 32, 16, will result in this. Eventually, the total will be like, I think, 256. And 256 because one of it is always used for, I think, multicast or something like that. I'll double check. And I'll add a fragment into the video. So, this is the network part. But because this part has 0, 0 is 0. Whether in binary or in dotted decimal, 0 is 0. So, this part is what the host can be. So if this is the part that the host can be, then how many possible hosts can we have? And this question usually comes out in exam for those that are writing certification. So it means that 256, another 256 multiplied by another 256, and this is how we arrived at 16.7 million. So this whole part is where the host can, take their numbers or identifiers from. Now for class B, it begins from 128 to 19. So when you see that the first octet is beginning from 128 or 129 till 191, then it belongs to class B. And for class B, the default subnet mask is 255.255.0.0. Again, these are the ones, these are the 0, the network part that everybody will share, like a neighborhood. And then the host part, where each device can actually pick their value from. And because we have only 2 parts, 2 octets, remember, 2 octets that comprises of 8 bits, 8 bits. So because we have this, then we have 256, 256, 256 multiplied by each other would result in this. And then the same thing goes for class C, which is commonly used, because most times in our home network, we don't even need up to, 256 hosts. We don't need up to, how many devices are you using in your home? on your local network or something that wants to connect to the internet, I'm not sure it's up to 256. So because of that, the default subnet mask is 255.255.255, which is the network, and then the host takes this part. And for the class D, usually it's those part of IP that are reserved or that people don't use. It's not a regularly used IP addressing. And for E also exists, but it's been reserved, so nobody is using this at the moment, or maybe for people in the military or whatever. So to buttress the point I was trying to make about binary notation of IP and the subnet mask, because we'll still eventually dive into subnetting. So as you can see that the IP are converted to binary. The subnet mask exists. As you can see from the image, it is a class C kind of IPv4. So because of that, it started from 192. And you can see that the default subnet mask for class C is 255.255.255.0. It's just to buttress the point, and every part that belongs to the ones when it comes to the subnet mask is where the host, the network can exist, and then the part that contains the zeros is where the host can exist. I hope to see you next week as we continue in IP addressing.